Hello, my name is William Pater.
And my name is Abhay. We are high school students and members of the high school robotics team. Will and I are now going to talk to you about robotic arms.
Have you ever seen a robotic arm? They can do a lot of helpful things, but sometimes they are too rigid and can only do a few tasks like move up and down or side to side. But what if you were able to design a robotic arm that could do things like animals? Sling a web like a spider, climb a wall like a chameleon, or fly like a bird. Many engineers are trying to create robotic arms that have features like an animal. Can you help create a robotic arm that can act like an animal?
A traditional robotic arm is rigid and unable to work closely with humans. But this new design that you'll be working on will be more flexible and less dangerous. A company has developed a new kind of adaptive gripper inspired by fish fins that is flexible and able to securely grasp even fragile objects, such as eggs.
A robotic arm is a type of mechanical arm, usually programmable, with similar functions to a human arm. The arm may be the entire mechanism or it may be part of a bigger robot.
Now we will watch a video on robotic arms.
So, when an engineer like you comes to the zoo,
Yeah,
do you see it differently from regular visitors?
I think so. Because we want to get inspired by the nature, and here in the zoo, there's so concentrated a huge variety of animals, all optimized for their applications. And we are thinking in applications, so this is a paradise for an engineer.
Heinrich works for an automation company trying to improve one of the most important inventions of the 20th century, the robotic arm. It's been revolutionizing factories since the first one was introduced in 1961 at General Motors. But robotic arms have some problems. Just like the one on humans, the traditional robot arm consists of rigid parts joined together, often limiting its programmable motion. They're also dangerous. Get hit by one of these, and it's lights out. So robots often end up behind protective fences, unable to work closely with humans. The German automation company Heinrich works for, Festo, decided to reinvent the robotic arm, making it more flexible and less dangerous. Heinrich leads me to the source of the inspiration, and it turns out maybe the best arm is a nose. So why would you look at an elephant's trunk and think this would help you with automation?
As you can see, it's so flexible and transmits a lot of force and makes it much more easier to handle things. And this is our business, handling things to automate a factory or a process. It makes sense to look into nature and to get inspired by nature. And the elephant is an excellent ambassador for that.
Thanks to Sella, a 47-year-old Asian elephant, I get a little first-hand experience with what an elephant packs in its trunk. Little elephant snot for you. An elephant trunk is an impressive multi-tool, able to slurp up water.
Now she collects the water.
Wow! And squirt it. Breakfast is on. It picks up food like a vacuum cleaner, manipulates objects, and it's strong. Sella can use her trunk to lift over 400 pounds. No, that's my wrist. She could crush me like a bug, couldn't she?
Yes, sir.
Here, have some more peanuts. But the trunk's most impressive attribute is its amazing flexibility. It comes from having no bones and about 40,000 muscles arranged lengthwise and in rings. With no bones and no joints, it's about as far away from a traditional robotic arm as you can get. I head to Festo's headquarters in nearby Esslingen to see their version of the elephant trunk. They call it a bionic handling assistant.
Yes.
Now this looks like a bionic handling assistant.
Yeah, you're absolutely right. This is our trunk.
Festo's version of the trunk is made of plastic, with a series of air chambers inside. Filling different parts with compressed air causes it to bend. So if I want it to bend that way,
We need a tube with compressed air for this expansion, and then you get this banding to the other end.
So this blows up like a balloon.
Yes, for sure.
They're testing the assistant with this simple motion for use in a packaging operation. Look at that, it tucks it in nicely. Well done, Dumbo. But it is inherently more flexible than a conventional arm, and, just as important, far safer.
We don't have electricity, we don't have steel and iron and all these masses which could damage a person. It's a weight of 5 pounds, some valves, a little control system.
So there's really nothing here but plastic tubes and air.
Yeah.
Does it do tricks? In this application, the tip of the trunk works by suction. But Festo has experimented with what it calls a fin gripper, inspired by fish fins. If you push on the middle of a tail fin, it doesn't curl away from you, as you might expect. It curls toward you, giving a fish much more efficient strokes. But Festo has built that principle into a gripper that curls around the object it needs to pick up, adapting to the shape. So it looks to me like you're about to demonstrate how this might work.
Yes, we have 2 different gripping devices, one with a fish tail, and this is a traditional one the robots are using.
Can I see these things close?
Sure. Same pressure, everything is equal. Now, we will see what happens. This is the old method, and this is the bioengineered method.
Okay, let the competition begin. Look at that! Traditional robot hand, shattered to smithereens, and the fishtail gripper really did its job. So you have Robot 0, Fishtail 1. You've stolen from nature and done a great job.
I hope you enjoyed that video. Now, before designing your own robotic arm, we're going to talk a little bit about the engineering design process. The 4 aspects of the engineering design process are exploring, creating, testing, and sharing. First, as you already have, you explored robotic arms and all the new ways that they're working. Now you're going to create your own solution to the problem, test it with your parents, and share it with the group.
Now, feel free to pause the video here and take out a blank sheet of paper and try to draw a robotic arm based off an animal.
I hope you enjoyed drawing your robotic arm. Now, pause the video and ask yourself these questions. How does a robotic arm help do things? What challenges did you have with your design? What is an animal robot arm able to do that a human arm cannot? What animals did you choose? And why would that animal feature be helpful?
Thank you so much for interacting and watching our video. I hope you all have a great day. Stay tuned for more.